All right, so actually we'll just do the three-step process up here that we did before. All right. What was the first step we said we needed? If we wanted to know how long an arc was, what is the length of an arc? What is, and again, the initial, I think maybe something like that. And we wanted to know the length of arc AB. Something like that. Somebody said something. What was the first step? That wasn't technically the first step, but when I said length, we said if you hear length, you're going to need circumference. So technically, that was step two. So we said if you see the word length or how long, we said you need, I don't remember how the wording went, but you need circumference. You had to figure out the circumference because that's the only thing really that's measured in length. Everything else is measured in like radians or degrees, which isn't length. So if you saw length, you need the circumference. So what was the step before that? What did we need to know before that? Phone should be up. Don't have any phones out. What was that first step? And it was the same first step for the other types of problems. If it was in degrees or radians, we still did the same first step. Oh, I can do it this way. I want to know the length of that. And I need to know how much of the circle does that take up? Not right now. So how much of the circle does that arc take up? So we said, okay, well then I need to know what percentage of the circle am I talking about? And it could be an arc, it could also be an angle. Sometimes we were solving for an angle. Um, Mostly it was arcs though, and length of arcs. But we need to know what percentage of the circle is that. What do we use to find the percentage of the circle? Well, what is a percentage? For a percentage, we do what? Part divided by whole, and we want to keep those units the same. So we said part divided by whole, and it's kind of like a little bullet under that. Keep the unit the same. And units would be like if it's degrees, then the top and bottom would both be degrees. The part and the whole would be degrees. If it was radians, the top and the bottom would be radians. You could get a problem. We're not going to do it in radians. You could get a problem in radians on the EFC. I think we saw one in the book where it was in radians already. So keep the units the same when you're doing that percentage. So that part divided by whole equals the percentage. And it'll be in its decimal, so you'd have to change it like into a percentage format. But so what was step three? Once we had done those two steps, all we had to do was what? Multiply whatever percentage of the circle we're talking about. So if that was 15% of the circle, we would say, well, what is 15% times the entire, in this case, circumference, if we're talking about length, we multiply the percentage times the whole. So we said multiply the percentage times the whole. And we said that the whole was really like, this is the units we are converting to. So if it was length, then we'd be multiplying it times the whole circumference in whatever, like centimeters, meters, whatever. If it was degrees, then we'd multiply by 360. If it was radians, we'd multiply times 2 pi. So whatever units we're converting to is the whole. So that was our three steps. So with that in mind, I want you to try to finish this one out. Oh yeah. Let's go ahead and start the bathroom. I'll give you a few minutes. Just make sure you are practicing this because this is pretty much your exit. I'm not doing a super long lesson on what the exit is because this is it. Change one little thing. So it is the lesson right here. Sitting there doing nothing, thinking you're getting a lesson in a little while, you're not. Yeah, I kind of need draw that circle real quick. Don't already have it down, so I can take this off or write the steps down or whatever you need. Oh wait, can I show? I might be able to show. Oh, they're not going to work though because they're not next to each other. Yeah, they're not next to each other. Let them copy it down real quick and trying to think of it. We're probably going to need to get some of his old page. This goes way back to the circles pages. I don't even know. I still have. Oh, I do. Yeah, here they are. All right, so we can find. Let me find. Yes. It's okay. Box. We're gonna go. Let me see how much of this it has in the new pages. Because it really is the same process. I just don't remember if they give us all that information over again or if they expect us to just know it from before. So let me see. I don't know if each department pages much. Oh, they just kind of give them the formula. Um, so just what pages? You have 285 in that book.
283, 295.
All right, so if he wants to go to 285, that's what we're on if we just use the new stuff. Well, 283 through 285. We don't I mean, we may do example one and example two, but that stuff's pretty easy. Example three is what the exit is. Example three is the exit ticket problem. Or similar to the exit ticket problem. All right, so a lot of people work. Oh, this is not what we're doing there. So working on that, that's something different. That's not what the exit ticket will be on. Again, you need to know how to do that stuff. I'm not. So just so you know, your book pages, I'm not quizzing you on example one and example two. You might see that on the EOC, but it's pretty simple stuff. You just plug in numbers into a formula. You're just solving for and we're going to do them real quick, but I'm not going to quiz you on that. That's not an exit ticket type thing. Those are super, super easy in my opinion. You're just plugging numbers into a formula. And you get that formula on the reference sheet. So this is more like what we need to know how to do. Focus on this one for now, because I'm not doing a big long lesson on it when we get to this section. Or this example. Example three is going to be more like your example. All right, so first step, how do I figure out the how? Let's kick it off with how. How do I figure this out? What's the percentage of the circle? Yeah, my part So then my part is in degrees. So what would I divide it by if I want to keep the units the same and my part is degrees? I divide by degrees, total degrees. So 35 divided by, so for step one, I'm just going to kind of squeeze it in a different color. So 35 divided by 360 gives me my percentage. Now it'll be a decimal, but I can then convert that to a percentage, or you can just leave it as a decimal. You don't have to make a percentage. What does that come out to be? Somebody do the math for me. Yeah, I was gonna say it's almost 10%. So 0.9 what? 72. So again, it should have been close to 10%, which that is, because 36. I know 36 over 36 would have been 10% or over 360. So that makes sense. So that looks good. Again, as a percentage, that's 9.72%. So just understand those are the same numbers. 0.972 is the same as 9.72%. If you put them into a calculator, you can either just type in just 0.972, or if you do 9.72, you have to hit the percentage button. It's the left parenthesis. You have to hit the second function and then the left parenthesis for percentage. Thank you. All right, so now we have step one done. Step two is pretty straightforward. We need the circumference. You want to know the length. So you'll get the formula for circumference. Again, I guess I'll just kind of make it really teeny tiny. It's either the diameter times pi, or in this case, what do we have? They gave us the radius, so I'm going to use the one with the radius in it. 2 times pi times r. So if I use this one with radius, 2 times the radius is 8. And then what is 8 times pi? So say it again, 25. All right, so that's my entire circumference. So that's the length of the entire circle, the line, you could say, that makes up the entire, oh, let's not do that. You'll be able to see that still, so let's use highlighter should work on this one. So the entire circle is 25.132. The 4 we multiply by 2. Yeah, that should be right. 2 times 4 is 8. 8 times 3.14. That's sense, right? Because 8 times 3 is 24, right? So it should be a little bit bigger than 24. So that's the entire circle. But again, I only want this little section from A to B. Really quickly, what would you guess? Like, how long should that be? If I know the whole green line is 25, what about would that be? Like, have an idea in mind you should get. Because I could kind of say, well, if half of it would be right here, right? This would be half of it. So that'd be like 12 and a half. A quarter of it would be like this. So it looks like it's about half of a quarter, maybe a little more than half of a quarter. So like maybe around 7 would be my guess, something like that. And again, I'm just doing that so I know when I do all the math that my answer makes sense. A lot of times if you do that, you'll catch mistakes in your math. I get answers all the time that don't make any sense because you guys just went through and did a bunch of math, but you made a mistake somewhere and you didn't even understand that doesn't make sense. So if I know the percentage of the circle, my angle is way off here. That's way too big because our number ain't going to match up with 7 and all of it. Yeah, gotta be close. Yeah, but that's because I think this is more like probably a 45-degree angle, not a. Because if 90 was right here, right? So if 90 was right here, that's bigger than 45 even, so probably even bigger than 45. So I just did not make a very good guess at that angle. So if I now say, well, I know the percentage of the circle, I know the total circumference is 25, I just multiply the percentage times the whole. Go back to blue, so my percentage, and again, you can do 0.972. If you do it as a percentage, you just have to remember to hit the percent button. So you have to hit that button times 25.152. And that equals, what do you get? 2.4 something? 0.44? So 2.44. So not even close to my 7, then I guess. But again, that's because I drew that. I just did it very short. You would have a drawing with more accurate. So yes, 35 degrees would really be in here when we draw it. Just to show you that would work if you had an accurate drawing. So 35 would be more. That's probably way over here. Oh, anyway. That's more fit. That's 90. That's probably more like 1/3 of 90. It actually probably still a little too big. So, any questions? That's the 3 steps that we did before. So that's a little bit of review for when you get one that says how long is the arc. Degrees was similar. It's just when we converted from radians to degrees or degrees to radians, we just didn't need this middle part. We just multiplied whatever the percentage of the circle was times either 2 pi if we were converting to radians or times 360 if we were converting degrees. Once we knew the percentage of the circle. So we did all of that before. Any questions? All right, so here's your new version of this. Not a whole lot different. You need it? Yeah. All right. Like at lunch meet? Yeah. So the first thing and I'm going to go over some of this pretty fast. First thing you need to know is the formula for area of a circle. Actually, you don't need to memorize it. It's on your reference sheet. So again, there's a section on circles. I'll pass these out in a minute if there's not one around you. There's some around you. You got some to your left, Sade, and beyond. So in the circle section, it has both of these two formulas, circumference and area. So you don't have to memorize that. You just need to understand what the pieces mean. Pi, I think we know what pi is, and r is radius. Now, be careful because we have a squared value on the radius, not times 2 squared. So you cannot use diameter. Make a little note in your notes. You can't use diameter for the area formula. So if they give you diameter, you have to divide by 2. The reason we could use diameter up here is because 2 times the radius is the diameter. There's no 2 times anything down there. Squaring is not multiplying by 2. Totally different math. Let's see. So what does area mean really quickly? What's area mean? Oh, come on. You guys got to know what area means. That's the space inside. So circumference is the length of the line that basically is the circle. Area, area is the whole space inside. So that would be the area of that circle. All that space inside. If we could measure all the space inside, that would be the area. And that it's measured in square feet or squares. Like it has a little squared symbol on the end, or they'll say square feet sometimes. That's because we're squaring that R. The only reason why they call it squared feet. All right, so here's the only piece that we're adding in. So to find the circumference, the area, we use that formula. So the problem you're going to do today and moving forward is I want to know what is the area? I don't have a picture. I'll draw a picture real quick. Oh, wait. So this is if you're given the area and you have to go backwards and find just the radius. Again, nothing changes. It's the same formula. Well, I shouldn't say nothing changes. You're just putting the area in here and then solving for R. Well, I'm skipping over that one so we can get to the one that's your exit ticket. Well, I still wrong. You got to make a ticket. And then did you see my message? Well, that too, but then about the field on Friday. Talk it over and see. We don't need it. Everybody doesn't have to do it. But if, well, we go on before the teams come out and like they'll announce the flag, and here's the flag or something like that. If we don't have to do it, but if enough girls want to do it, we can do it. All right. Yeah. All right. So here's the example. 3. So in the problems, they want to know just what is the area of that one section. Again, real life, you can think of it as a piece pie out. What is the area of just that piece pie? What's the area of one piece pizza? Like all kind of things that can give you a visual. But basically, you're solving by finding the area of the entire circle. So we find the area of the entire circle. We find out what percentage of the circle is that piece. And then we say, okay, well, if I know the entire circle is the area is 100 square feet, I know that percentage is 20% of the circle, then we just do what we did in the other problem. We say 20% times 100, and that gives us the area of just that piece. So with that in mind, I'm not doing it the way they did it in the book. If you want to try to memorize formula, can, but again, if the problem changes a little bit on the EOC or we don't really have a quiz left, then you need to be able to adjust to it. So if you're just plugging stuff into a formula, that doesn't always allow you to adjust on an EOC. So go to example, I think it's 3. Do not look at, oh God dang it. Here, I'm going to give you the shortcut right now. So they are telling us actually in this problem how many sections we have of the circle, right? They're telling us we have 6 sections. And they're all equal sections in this problem. Now, I could do the same exact process. I could figure out, okay, what percentage of the circle is one section and go through all those steps. But if I know how many sections, what would I really just be doing if I knew the whole area? What I really just need to do to find one section? I just divide by 6, right? If I know that this, I'll just make it easy, this whole piece of pie is an area of 12 puzzles. What would one section be if there's 6 equal sections? 2, right? I just divide by 6. So if you know how many sections and you know they're all equal, you don't really have to go through that whole process. Just find the total area and then just divide by how many sections. So again, same thing down here. If you know how many sections, so they do a dartboard. If you know how many sections, so 12 sections, I can just find the area of the whole dartboard and divide it by 12, and that'll be one section. Again, I'm not going to do those. I forgot we did them in the other class, but that's not the way you're exiting it. So we're going to go, so turn to your practice problems, and we'll do one from your practice problems. It's more like the, so look at number 13. Be a little rushed on the exit ticket, but try to do 13 on your own. Use the 3 steps. I need to know what percentage of the circle am I talking about. So that red slice, what percentage of the circle? I want to know area, so I'm going to need to figure out the total area of the whole circle. So that's just a formula. I'll write that up since I haven't given you the reference sheets yet, but some of you, I think, had some around you. I'll pass them out while. So I need to know what percentage of the circle, what is the total area, and then you just multiply those two things together. And that's the area of just that section. You guys work on that? Anybody that doesn't have one of these? You don't have one, you doing it? Not that difficult. What do you that one? You need one code? Every. The main one he needs is under formulas with this circle. Really helps. As long as he's got that today, he's fine. So you have him, if he can try that in his book. And yeah, I'll probably give him one today to try. So I'll give you a couple more minutes and then we're gonna wrap it up. We'll see how we feel about it. Schedule thing is really throwing off. I thought I was gonna be able to get you 10 people. Question or usually question? Check the answer done. Right. That looks good there. That's not math. You did it's where the rate. It turns out it turns out to be the same answer, I think. Because 2 squared is the same thing as 2 times 2, right? So actually your number will be the same, but just be careful. You have remember in this formula you are squaring whatever the radius is. Don't multiply by 2, although that happens to work in this case because 2 squared is the same thing as 2 times 2. But when you get other numbers like 18 or 12.5, you need to say 18 times 18. That's squaring. 12.5 times 12.5. Not times 2. Squaring it in. Yeah, it's the same thing when the number is 2. When you find that you skip through. When you find what percentage it is? Yeah. So if you have the decimal still on your calculator, you could just use that number. You don't have to make it a percentage. I've been converting it to a percentage to try to give you something that's like a conceptual thought because I think we understand what a percentage is. Like I know what 50% is or 25% is, as opposed to using a decimal. But just to understand when you do the math, a decimal is the same thing as a percentage. We're just moving the decimal around. So you could just say point. What did it come out to be? 0.1. 1.19. No, the percentage. So did you do 51 divided by 360? Yeah. So what did that come out? 1. No, not 1.0. 0.19, right? So you could just take that 0.19 whatever and then use that number at the end. Or you need to change it to 19 point something and then use the percentage. So let's go ahead quickly and go through it. Again, if you're not getting it, it's not gonna exit tickets can't hurt you, but at least you'll get this one in today. So I need to first of all find out what percentage of circle. Well, keep the measurements the same. So if they give me degrees, I need to divide by a whole circle in degrees. And we just said what the number that gives me is 0.19. Oh, I could have sworn he was saying 19. 0.14. Where in the world did I hear? I'm gonna round it a second. So I don't know where I heard 1.9. So that's my decimal again. That would be 14.17%. You can just leave it like that. Now I need the entire area. Well, I just plug numbers into a formula for that. So 2 squared is 4. 4 times pi is what? What'd you get? Should be 12 or 13. 12.56. So that's the total area, the whole circle. So if I'm just guessing, and again, their pictures are more to scale. So if I'm just guessing, well, how much of the circle, like how many sections of that would I have? I don't know. There, there, there. So I don't know. 1, 2, 3, 4, 5, 6, 7. So I should be like a little over 1.5, maybe something like that. Just as a guess. That's how I could just divide that by 7, and that will give me 1 section. But the real math is I take the percentage, so 0.1417 or 14.17, whatever you want to make it, times the whole, which is the area, the whole area. So you should get that statement, and then what does that come out to be if you do it on a calculator? 0.1417 times 12.56. Yeah, so 1.7-ish would be the area. So again, 12.56 is the area of the whole circle. 1.7 is the area of just that section of the circle. And if they were all 1.7, I could say, well, does that make sense? Like, would that add up to about 12.5? Well, if I multiply 1.7 times, really can't draw it out though. 7? Maybe I could. What is, just curious, what is somebody on a calculator, what's 1.7 times 7? Well, that's pretty close to the 12.56. So again, just try to make sure your answer makes sense. What? Yeah, we're doing it right now. So again, not a lot of time to practice. Just remember that project. Take a breath, put yourself up, find the percentage of the circle. So again, you use the degrees they give you divided by total of 360. That's your percentage. Find the area, make sure you do the formula correctly and square the radius. And then you just multiply those two things together. I need you to number off for me. We'll start. Calvin, you're going to do something different. Anthony, you're a 1. 2. Actually, I guess I'm calling. 3. 1, 2, 3, 1.